I'm going to teach you PERT, Program Evaluation and Review Technique. For this purpose, I have taken a small problem where you have around 3, 6, 7, 8 activities: 1 to 2, 1 to 3, 2 to 4, 3 to 5, 3 to 4, 4 to 6, 5 to 6, and 6 to 7. Uh, Now we are going to read out the further things in this PERT. In PERT, you will be given 3 timings. The first one is called as the optimistic time. The optimistic time you can see here, which is referred as A. And then you have the most likely time, and then you have the pessimistic time. This optimistic time are very confident people. They do the work quicker and faster. They complete the task rather sooner. Whereas the pessimistic people take their time, they do slowly, they are very reluctant to do the work. That's the reason why you can find the pessimistic time is always much larger than the optimistic time. And the most likely time stands between the optimistic and the pessimistic time. So in this case of problem, which timing should we use to find the project duration? From these 3 timings, you cannot choose any one in particular. If you choose any one in particular, you will end up with the wrong project duration, because you might base your answer on optimistic, but the people who work for you might be pessimistic. If you base the answer on pessimistic, you will be too late in completing the project. You might not get the project completed on time. So what is expected is you should find the time which is average of these timings. We call that timing as time expected. This time expected is actually the weighted average time of these 3: optimistic, most likely, and pessimistic. Normal average is add for each activity the 3 timings and then divide it by 3. It is a simple average. Say for example 1 to 2, the simple average will be 3 plus 5 is 8 plus 7, 15 divided by 3 is 5. But rather, now we are going to employ weighted average method. As per this weighted average, the weight for optimistic is 1 and for pessimistic is 1, and for most likely it is 4. Which means, what is the weighted average formula? That is the time expected formula is A plus 4m plus B, divide this by 6, because the sum of the weights is 6. A is 1, B is 1, and M is 4. 1 plus 4, 5 plus 1 is 6. So if you use this formula for every activity, you can find the time expected first, which can be used in calculating the project duration. Which means for the first activity, 3 plus 4 into 5 is 20 plus 7. 3 plus 20 is 23 plus 7, 30. 30 by 6. 30 by 6 is 5. Similarly, you can try for the next one. 4 plus 4 into 4, 16 plus 4, 20 plus 4, 24 by 6 is 4. Third one, 7 into 4 is 28 plus 5, 33 plus 15 is 48. 48 divided by 6 is 6 8s are 48. Then you can try for the next one. 4 into 3. 4 into 3 is 12 plus 2, 14 plus 6 plus 16, which is 30 by 6, which is again 5. Then 4 into 10, 40 plus 7, 47 plus 31 is 78. 78 by 6 is 13. 78 by 6 is 13. Then 4 into 6 is 24 plus 2, 26 plus 10, 36 divided by 6. 36 by 6 is 6. 412, 48 plus 9, 57 plus 21 is 58, 78, 78 by 6 is 13. Then 8 into 4, 32 plus 6, 38 plus 28. 58, 66, 66 divided by 6 is 11. So which means time expected for each activity we have found using the weighted average method. Now we can draw the network and use these timings in the network to find the project duration. Right. So let us go for the network diagram. First is go for a new share. Share is the key. So let us draw the network. First 1 to 2, then 1, 2, 3. 1 to 2, and then 1 to 3, let me Windows here. I think it's better I move to the Word document where it is much easier. Take insert option, shapes, circle. Two, this is text. Here, insert the circle. right? 1, 2, 3. Here, this is 3, 1 to 2, 1 to 3, 2 to 4, 3 to 5, 4, and take from 2 to 4. Let us have 4 here. It is 2 to 4. Then you have 5. 3 to 5 we can take from 3 to 5. Okay, copy this, paste it here. This is 3 to 5. Then you have 3 to 4, 4 to 6. 3 to 4, 3 to 4. To then you have 4 to 6, 4 to 6. Then you have 5 to 6, 6 to 7. 5 to 6, 6 to 7. Just in this little so that I can fix the to 6 to 5 to 6 to 7. So the diagram is done, networking is done. Only one starting point, one ending point. What is our next task? Come with the starting time in the ending. For activity 1 to 2, the time expected is 5. So we'll start with 0, end at 5, 0, comma 5. In activity 1 to 3, it is 4. So it is starting and it ends at 1 to 2, 1 to 3. Then 2 to 4, 2 to 4. See, once the 1 to 2 is completing at 5, that means 2 can start only at 5. So 2 can start at 5. So 5 it starts, and 8, which is 5 plus 8, 13. Then it is 3 to 5, 3 to 5, 3 to 5 and 3 to 4 can start only after 1 to 3 is completed, which means at 4 it can start. It starts at 4. Similarly, your 3 to 5 can start at 4. 3 to 5 is 5 days, which means 4 plus 5 is 9. And 3 to 4 is 13 days, which means 4 plus 30, 17, by 4 to 6. 4 to 6 going to be somewhere around 6 is somewhere 6 days. So once 2 to 4 and 3 to 4 is complete, then only I can start 4 to 6. This 13 days for 2 to 4, 17 days for 3 to 4. So I can start only after 17. I can't start much earlier than that. 17 plus 6 is 23. Then 5 to 6 I can start after completing activity 3 to 5. Right? So 3 to 5 is completed at 9, which means I can start at 9. Then 5 to 6 completion time is 13. 9 plus 13 is 22. Then when you come to 6 to 7, it is a toss off between 4 to 6 and 5 to 6. And the higher timing should be considered. Higher timing is 23. 23, comma 11 is 34. So the project completion time works out to 34 days for the entire project. So from here on, you can find the backward timing. When it comes to backward timing, I'm going to use a different color here. Let us use a red color for the backward timing. The ending time is 34, finishing time is 34. So what we will have to do is we will have to go back by starting with the finishing time, which is 34. 34. If you are going to finish at 34, when will you start? When you should suppose to start the activity 6 to 7? It should start 11 days before 34. You very well know the timing, the time expected for 6 to 7 is 11. So 34 minus 11 going to be 23, right? So in this way, we found out the backward timing. The 34 is the project completion time. So that is taken first. With this 34, I have subtracted the project duration, the time expected for 6 to 7, which is 11, which means 23. 34 minus 7 is 23. Now 6 to 7 should start at 23, which means 5 to 6 must complete at 23. Must complete at 23. They had to complete at 23. When should they start? 23 minus 13, which is 10. So using this backward timing, I take this starting time as the finishing time here, and when this is the finishing time, when should it start? So finishing time minus the time expected, that is here for 5 to 6 it is 13. 23 minus 13, I'll get the starting time. See, the concept of the forward time is called as earliest starting time and earliest finishing time, and the concept of backward timing is called as latest finishing time and latest starting time. So basically we find the latest finishing time and the latest starting time when we return backwards. So similarly you come over here, 23 is the starting time for 6 to 7, which means 4 to 6 should have completed in 23. So if it completes on 23, when should it start? 23 minus 6 is 17, which means it should start on 17. When it should start on 17, the activity before 4 to 6 is 2 to 4 and 3 to 4. They should start at 17. They should end at 17 because 4 to 6 starts at 17. 2 to 4 should have ended at 17. Right. So what we are going to do is we are going to bring it here. So it should end at 17. If it should end at 17, at 17, when should it start? 17 minus 2 to 4. 2 to 4 is 8. 17 minus 8 is 9. So it should have started at 9. And similarly, 3 to 4 is based on 4 to 6. 4 to 6, you are starting at 17, which means 3 to 4 should have ended at 17. If they are going to end at 17, when should they start? When should they start? 17, 3 to 4, 3 to 4 is 13, 17 minus 13 is 4. So their starting time is 4 and finishing time is 17. Similarly, 3 to 5, 3 to 5, the starting time of 5 to 6 is 10, which means 3 to 5 should complete at 10. In that case, 3 to 5, the duration is 5. 10 minus 5, it should have started at 5. Now it is activity 1 to 3. There are two timings. 3 to 4, starting time is 4. 3 to 5, starting time is 5. When there are two timings and when you come backward, choose the smaller timing, which means 4 is the smaller one. Choose that. So which is 4, the finishing time. That means 1 to 3 is 4. 4 minus 4 is 0. So now you are more or less on the verge of completing this, because in the last one is to 1 to 2. So this 9 should come over here. Then 9 is the starting time. That should be the finishing time. So 9 minus 5 is 4. Right. If you check the earliest starting time, earliest finishing time, the latest starting time and latest finishing time, if the time matches, you already know it is the critical activity, which means 1 to 3 is a critical activity. So what we will do, we will make note of the critical activities. 1 to 3. Then the 3 to 4 is a critical activity because 4:17, 4:17, the timings are the same. So 3 to 4. Then 4 to 6, 17:23, 17:23, 4 to 6, and then 6 to 7. So these are the critical activities, and the project duration is going to be 34. Project duration is equal to 34 days, and critical activity is 1, 3, 4, 6, 7. See, after this, next general question, what they are going to ask you is going to be, apart from uh, network, is the regular question. Then find project duration. Then find critical path. After this, the next major important question is find the total float, float, and independent float. In case of PERT, they ask you find the standard deviation of the project, find the variance of the project, and find the standard deviation of the project. So what should we do if they ask you to find the variance of the project? Okay. Here what you do, a very simple technique. First draw a table with first activity, then duration, then activity A, M, B, duration. Then you can go for standard deviation of the project and variance of the activity, optimistic time, most likely time, pessimistic time, time expected, then standard deviation, variance, activities, 1 to 2, 1 to 3, 2 to 4, 3 to 5, 2 to 2, 1 to 3, 2 to 4, 3 to 5, 3 to 4, then 4 to 6, 5 to 6, 6 to 7, 4 to 6, 5 to 6, 6 to 7. Timing for these activities 3, 4, 5, 2, 7, 2, 9, 6. 3, 4, 5, 2, 7, 2, 9, 6. Optimistic time. Most likely 5, 4, 7, 3, 10, 6, 12, 8. 5, 4, 7, 3, 10, 6, 5, 4, 7, 10, 10, 6, 12, 8. 10, 6, 12, 8. These are taken from the problem. The pessimistic time is 7, 4, 15, 16, 7, 4, 15, 16, 31, 10, 21, 28. 31, 10, 21, 20. You already know the time expected. You have already found it. 5, 4, 8, 5, 13. 5, 4, 5, 13. 6, 13, 11. 6, 13, standard deviation. Standard deviation, there's a simple formula. Formula is P minus A divided by 6. P is P radical, B or pessimistic. A is optimistic or O, P minus O by 6, which is 7 minus 3, 4 divided by 6, which is 2 by 3 is 0.67. And next is 4 minus 4, 0 by 6 is 0. 0 by 6 is equal to 0. Then 15 minus 5 is 10 divided by 6 is 5 by 3, which is 1.7. Then 16 minus 2 is 14 by 6 is 7 by 3. 7 by 3 is 2.33. Then 10 minus 2 is 8 by 6. 8 by 6 is 4 by 3, which is 1.33. Then 10 minus 2 is 8 by 6, which is again 4 by 3, which is 1.3. Then you have 21 minus 9. 21 minus 9 is 12. 12 by 6 is. Then you have 28 minus 6 is 22. 22 by 6 by 2 by 6, which is 11 by 3, 3.67. Variance is equal to SD square. SD square, which is 0.67 square. So I put here calculator for quick calculations. 0.67 into 0.67 is 0.4489. 0.4489. Then the next one is 0. Then 1.67 to 1.67, 2.7 W89, 2.7 W89, 2.33 into 2.33, 5.4289, 5.4289, then 1.33 to 1.7689, 0.7689, 2 square is 4, then 0.67 into 3.67, 13.4689. Now you know the critical activities. Critical activities are 1 to 3. They are critical activities. Then you have 3 to 4. 4 is again a critical activity. I'm just holding it. 4 to 6 is a critical activity. 7 is a critical activity. Take only the critical activities variance. Variance of the project is equal to of the project is equal to 0 plus 1.7689 plus 1.7689, 1.7689 plus 13.4. One 17.0067, 067, which means standard deviation of the variance of the project is 17 days. In case the question asks what is the standard deviation of the project, standard deviation of the project is equal to square root which is QRT, QRT 17.0067 the square root of 17.0067 is 4.1239, 4.1234 days. Right. So PERT is actually probabilistic method where you're going to find out what is the probability or the probabilistic time to complete the project, what is the standard deviation to for the project duration, what we have found. We found the project duration is 34 days, but it has a variance of 17 days plus or minus, and on an average, the mean or the standard deviation from the 34 days of completing the project is around 4.124 days. Right. Here I can, there's one more question that can be asked here. Find probability complete the project in, let us say, 37 days, 38 days. This is the usual one. Usually we do the normal distribution where we tell probability of some x, probability of some x is equal to x minus mu minus mu divided by standard deviation. It is modulus modulus of x minus mu by standard deviation. No negatives, only positive should be taken. Minus mu insert symbol x mu modulus the standard deviation. If you use this formula with the modulus bar, here you will come across x minus mu. X is the number of days which I have asked here, and that is probability of 38 days, which is equal to modulus of x minus mu. 38 minus 34. 38 minus 34 modulus by standard deviation 4.124. End up with the answer 4 divided by 4.124 divided by 4.124, which is 0.969. We can take that 0.96. Required only two decimal places, so it is 0.97. So what we'll have to do is go to a standard normal curve table, because you all know the standard normal curve like this and like this. So hand drawing probably with the mu in the center. The mu in the center, and the mu is going to be 34 days. And the question asked here is 38 days. If you come somewhere over here, 38 days. So that means somewhere over here. So 38 minus 34, you have got that 0.97. The area what you're going to find is for this part. The area what you're going to find is for this part. This is that area what you require. You're going to find area what you're going to find. And that area you should find using the table standard normal area table. You'll understand the standard normal distribution for 0.97. For 0.97 is 0.3340. 0.3340. So normally it takes zero point 0.5. Probability to complete the project in 34 days is 0.5. Probability is basically 0.5 now. You are going to move further. When you move further, the probability of completing it gets extended. So for 0.97, it is 0.3340, 0.3340, which means the probability to complete in 38 days is going to be 0.8840, 0.8840, 0.8840. In case the project completion time is preponed or asked earlier than 34 days, you find the areas using the same formula, you will get one answer here. For this, find the area, but you should subtract that area from point size, because the earlier is difficult to accomplish, the probability will be lesser. The delayed or the later time than what you are going to calculate, right? If it is more, if the probability of asking a higher duration, the chances of completing is much higher. So in case if I tell if it is probability of completing in 30 days, so 30 will come somewhere here. 30 will come somewhere here. Then it is 30 days. Here it will be 30 minus 34, 4 divided by 4.124, modulus will be 0.97, and it will be the same 0.3340, right? As a result, 0.5 minus 0.3340, because it is preponed or earlier than the normal time, it is subtract later than the normal time, it is addition. So if it is probability of 34 days, it is going to be 0.5 minus 0.3340, which is 0.5 minus 0.166, right? And this is PERT. I hope you don't have any doubts. In case you have doubts, you can always contact me. You have my contact details. With this, I'm closing the session of PERT. Thank you. Thank you very much.